Yeah. So today we'll discuss about Azure load balancing concepts. So in Azure we have four types of load balancers. First one is called as Azure Load Balancer, then Azure Application Gateway, then we have Azure Traffic Manager, then Azure Front to Door. So these are the four types of load balancers we have. The traditional normal network load balancer is Azure Load Balancer, and normal layer 7 we have application gateway. And what is the difference between traffic manager and front door also we'll discuss. So what is the concept of load balancer? Load balancer will take the traffic from the users and redirects to the healthy target. Always what load balancer will do is load balancer always will take the traffic from the users and redirects to the healthy target. And what is the Azure Load Balancer is? Azure Load Balancer works at the layer 4 and it's going to redirect the traffic to the targets. So what are these different types we'll discuss. So here load balancing refers to efficiently distributing incoming network traffic across a group of backend servers. In our environment, those backend servers are virtual machines or virtual machine scale sets. And even going forward, we can attach to like a Kubernetes containers also we can attach. And the load balancer, so whenever we are talking about Azure load balancer, it's a network load balancer kind of thing, and it works at layer 4. Backend, we may have thousand like VMs also. Load balancer is the single point of contact for our clients. Then load balancer, whatever the like uh, inputs comes from the users, load balancers distributes that to the backend instances, to the backend pool instances. It's going to be configured. So this here, as we discussed, the backend pool of instances can be Azure virtual machines or instances in a virtual machine. And in the load balancer, we have two types of load balancers. One is public load balancer, like over the internet it is going to take, and internal or private load balancer. This will work only within the VNet kind of thing. Only for the intranet sites, if we want to configure, then we are going to use the internal load balancer, and over the internet public load balancer, we can configure like over the public IP, we are going to access that website. So in this, like here, this is the load balancer, and like here, these are the backend pools. We are going to hit this load balancer, and it is going to take the decisions. And what is the meaning of front end is the IP address to which users are going to hit it. The front end IP for the public load balancer, it should be the public IP address. And for the private load balancer, not mandatory, should be public IP. Private IP address also is going to be accessible. So we need to configure the front end IP. As we are going to configure internet base, definitely we required public IP address for the front end. Then what is the meaning of backend pool is? In the backend pool, we are going to keep the Virtual machines are instances, or sometimes we can keep scale set also. That means uh, I want automatically scale up or scale down depends upon my load. Then we are going to use the scale set. Okay, so instead of keeping virtual machines for the high availability and for auto scaling, better to go for the scale sets. And those missions have been added to backend pool. So the health probe. Health probes we need to configure. These health probes are keep on checking the health status of the instances in the backend pool. And if the health of the virtual machines are not good, then automatically the load balancer will remove that server from the backend pools. And if the probe, it's a listener kind of thing. Here in Azure, we are calling as the probe. And when the probe have been failures, the load balancer stops sending new connections to that unhealthy instance. Okay, so that is the reason always load balancer will take care redirecting the user traffic to the healthy instance at any point of time. The user is going to be connected to healthy instance itself at any point of time. It's going to be connected. What is the responsibility of the listener is the listener port has been under, like we need to configure, and it's going to check whether that port has been working fine or not. Okay, so that's it need to check. So even the pro fails, even if the VM shutdown also idle timeout is occurring, that service is not listening, port is not listening, then it's going to be probe is failure is going to happen. And finally, all these we are attaching to a load balancer rule. So in the load balancer rule, we are going to map the front end IP, the backend pools. Here, these are all the backend pools, and that load balancing rule. All these we are adding to the load balancer rule, and those probes also we are going to attach to the load balancing rule. And here, based on the load balancing algorithm is going to use the source IP address, source port number, destination IP address, and the destination port protocol. So these all depends upon these five factors. Load balancer is going to take care the load balancing algorithm. It's a hash base, and it's based on the five tuple or five rules of connections it is going to take. So previously we have round robin kind of thing. What is round robin is the first request goes to first server, second request goes to second server, third request goes to third server. Like this, we used to connect to those devices. But here now in Azure, for the load balancing, they're going to use the load balancing algorithm is a hash based algorithm, and it's a five tuple connection, and based on the source IP address, source port number, destination IP address, destination port, and protocol, the connection is going to be established. The connection is going to be established. And definitely we need to configure an inbound rule also. At the inbound rule, what is the port number? Like maybe if it is a web 80 or 443 port should be opened. Say here Azure Load Balancer uses, not like round robin or least connection, not based on this. It is using five tuple hash. And what is the meaning of session persistency is or it's maybe called a sticky session. If the user already connects to that server before, and if you enable session persistency, the user is going to connect to the same server irrespective of that load balancing rule. That means if you have a session persistency and load balancing, the priority would be given to the priority would be given to the session persistency. That means already we have a session has been established. Due to some reasons it disconnected. Again, we are going to connect to that. Then, like session persistency will comes into the picture than load balancing. That means to the same server, it is going to be connected. That means the same the successive request from the same client IP address is handled by the same client device. Okay, so that's like here it's maybe either two tuple or we are going to add even the protocol also. So from this, it is going to redirect to the same server. Say here load balancing is not coming into the picture, session affinity is coming into the picture. If you enable, like for stateful applications, the user need to go to the same server. Again, restarting from the server, new server is user will connect from the new session. That is the reason we are using session persistency. That means you are in middle of some application. If you start it from starting, again user need to do it everything from start itself. That is the reason we need to go for like the new session need to be connected. The new session need to be connected. So here if this is the mission which is connected, but as per the load balancing, even it need to go to this third VM. Here this will redirect to this first session itself, because here already our application has been running, and from there we want to continue, not from the starting of the session. So that is the reason we are going for the same IP we are going, or same backend device we are going to connect. So if the session like persistency or session affinity is there, load balancing is there, the priority would be given to the priority would be given to it would be
Same
given to the
session.
session persistency itself. For that we need to enable the session persistency. Okay. So then say here we discuss about the load balancer. Load balancer works at which layer? It works at the layer 4. Layer 4. Okay. So then application gateway works at layer 7. It is mostly for the web traffic. Okay. The traditional load balancers operate at OSL layer 4 TCP and UDP level, whereas the Azure application gateway works at the like mostly the HTTP HTTPS level is going to work. And application gateway works based on like path based routing and URL based routing. So what is the meaning of path based routing and URL based routing, we'll discuss. So now here we have one application. So what is the domain name is contoso.com, and if it is slash images, this is one backend pool, and slash video, so this is one backend servers. That means same domain, the path of the application is different, and based on the URL path, we need to take the decisions to which backend pool it need to redirect. So that means we have two applications in two different path. That is possible to configure with That is possible to configure
Mhm.
with the application gateway. The path-based routing. What is the meaning of path-based routing? What is the meaning
Yeah.
of path-based routing? Say we have the same website domain, but if it is slash like images is one path, slash video is another path. If we have this kind of requirement, then we are going to do the load balancing using application load balancer. This path-based routing is not possible with the network load balancer. This path-based routing is not possible with the network load balancer. This is possible only with the application load balancer. Only with the application load balancer is going to happen. Then application gateway is supported with web application firewall for our websites. Like maybe we need to protect from the hackers or SQL injections, DDoS kind of protections. All these like web application firewall also it supports for the web-based applications. Okay, so that is layer 7 load balancer. We are going to configure. So now here we have application gateway front-end IP, and we are going to configure here the probe is HTTP as listener, and based on the rule, it's going to redirect to either VMs, VM scale sets, or on-premises servers also it can redirect. And in the HTTPS communication, we need to choose the point where our HTTPS traffic need to be redirected to HTTP traffic. This point is called as either TLS termination or SSL offloading. So, what is the concept of SSL termination or TLS termination is? What is the concept of it? What is the concept of this? Say by default the
External
traffic is
security.
coming from HTTPS, but at some point it need to be redirected to HTTP. That decryption need to happen or encrypted in need to happen. But instead of doing that at the backend servers, we have chosen at we have chosen at we have chosen at the application gateway. Okay, so what is the advantage that is? If you have 1,000 backend servers, in each and every backend server, we need to configure the root certificate for the decryption. That's very like costly kind of encryption and decryption overhead. If you allow that at the web server level, if you do, instead of that, what we need to do?
Enable application gen.
Yeah, we need to enable at the application gateway. We are going to choose the TLS
Yeah.
or SSL termination point. Then, it's easy to configure at the single point of location. Otherwise, in each and every web server, we need to configure those. Okay, so now, like before client sends a request to it resolves the domain name application, like we'll have the DNS name, that Azure DNS will resolve to that, and to the front end IP of the application gateway the user request comes, because the user directly may not use the front end IP of that, he may use one domain name that's going to be resolved at Azure DNS. Then Azure DNS returns the IP address to the client, then accept that input traffic and listener, and based on that web application firewall also will check the user request body is WAF rules, and if that is not against it, web application firewall doesn't forward that request. And the threat detection and any fraud, any URLs, all these also is going to check. Okay, then it's going to do the uh, decryption also of the traffic, then it's going to be redirected to the users. So now here, Like whenever the front end IP, say this is mostly the virtual IP kind of thing, and it's going to be forwarded to the listener, and the listener will have the rule, and based on the rule, it's going to be configured to the backend instances. And here we are going to configure one root certificate also. Using that certificate, whatever the HTTPS traffic is coming, that is going to be redirected. That is going to be redirected to HTTP, and based on that it is going to be configured. And here also we'll have a application gateway, also will have a load balancer, and definitely we'll have the probes and listener rules, and finally we'll have the backend servers, and attaching to load balancer rule we are going to attach to those. Okay, so then the third one is the traffic manager. So mostly the application gateway scope is within the region itself. Application gateway scope is within the region, whereas load balancer works at global also. So what is the meaning of region? Only within the region we are going to configure this. Within the region we are going to configure the
Gateways,
yeah,
application.
say within the region we are going to configure the application gateway. But whereas load balancer works at the global level also. And we have Azure Traffic Manager. Azure Traffic Manager is a DNS based traffic load balancer. And at the DNS level, I have globally multiple locations I have. Means I have 4 regions. Across the 4 regions, I want to do the load balancing. Then I need to go for Traffic Manager. Here Azure DNS is playing a vital role. Whenever we type the website, based on the like DNS, it is going to take the request to the appropriate maybe it's a global site kind of load balancer. Okay, say it's going to do application manager will take at the site level, like a global site level, it can do the redirection. So that's will configure the next class. So today we'll discuss about load balancer and application gateway. So we'll go to Azure portal. So now here we are going to choose so any VM scale sets or those we have. We have already Finexo app scale set is there. And this is JPMC VNet 392 is there. Using this, we'll try to create one load balancer. So now here in the load balancers, we can choose the Azure Load Balancer, Application Gateway, Front Door, Traffic Manager. So what is front door and CDN also we'll discuss. So as of now, we are going to create a load balancer at the UDP TCP level. It works, and I'm going to create a load balancer here. Okay, so now in the load balancer, we need to configure the front-end IPs, back-end pools, inbound rules, outbound rules, tags and reviews. So before itself, I'll check those public IPs because we are getting a shortage of public IPs. Okay, as of now, 2 we have. I'll try to create one more for if it is private load balancer, we no need of a public IP. But we are creating internet base. So load balancer, create a load balancer. Already we have JPMC. JPMC load balancer and standard we are choosing. So gateway also we'll discuss what is the gateway kind of load balancer, and we are creating a public base. And here for the load balancer, it supports both regional and global. We are choosing regional. Then here we need to add a front-end IP. For that front-end IP, we need a public IP. Front-end app, IPv4. Say here we need to choose, create a new IP address. That front-end IP to be created. Then we need to add the backend pools. In the backend pools, we can choose either like VMs or VM scale sets. We can choose. And network, we need to choose this VNet because our VMs are in that VNet itself. Our VMs are in that VNet. Okay, so that is the reason. Either based on the NIC or IP address, we can add those. So in this, we have two missions are there. Our scale set also we have. Either VMs we can add, scale set, which is recommended to add, is scale set is recommended because if any new missions have been added or deleted also, if you create the individual missions, those new missions would be not added. But here if you add the scale set, and from that scale set, if any new missions have been provisioned depends upon the load, those would be attached to the load balancer itself. Those would be attached to the load balancer. So now here I'm going to add the backend pool, and we have chosen VMs or VM scale sets. Which one we have chosen? So we have chosen here in our scenario VM scale sets. In the last session, we created the VM scale sets. Those VM scale sets we have added. Okay. So then I'm going to save them. Then the inbound rule. Mostly we need to add the inbound rule. Load balancing rule. And here I'm going to attach that front-end IP and the backend pools and TCP level, UDP level. Why we are using TCP, UDP is this is at the layer 4 it is working, and the port is 80, and the backend also 80 we are configuring, and we need to check the health probe. We are going to configure the health probe. TCP AP is going to be verified, and for every 5 minutes it's going to check. And if we want the session persistency based on the cookies like this, we can enable the session persistency based on the client IP or based on the client IP and the protocol. As of now, I'm not choosing any session persistency. I'm going to configure the outbound rules. Anyhow, we no need of more traffic need to be allowed. See here we have added the outbound rules also, but inbound rule is important. From the load balancer, mostly the outbound traffic is not going to happen. Then we are going to create that load balancer. The users are going to access that application, like from the front end IP of that load balancer, they're going to access the website. And finally, what we need to do is we have our domain name, and the domain name need to be linked to with our like a front end IP of the load balancer. We can do it from Azure DNS wise. Okay, normally DNS, what it will do is whatever the front end IP is coming, it is going to be redirected to that instance. So in our scenario, like load balancer is going, sorry, DNS is going to configure that one. Failed something. The outbound rule we have. Again, I'll configure. Outbound rules are getting conflict. So here, most of them created that outbound rule wise, we got the conflict. Say this front end IP, what is the front end IP we got is we don't hit, we have two VMs or maybe 100 VMs in your scale set also. Those IPs we are not giving to the users. Like from this front end IP itself, that application should be given to the users. But for these websites, it's recommended to go for like a application gateway is recommended where we can do the path-based routing. But here in TCP also, we given 80 itself. And once we go and check that health probe, 80 level we have configured, and the backend pools are the VM scale sets. Here this website is accessible. At least one instance, if it is accessible, it need to come to that front end we have back end pools are there. Then health probe. So with the scale sets also we'll add it, but here, like if this one any of the instance is down also, you have two instances in that scale set. One instance down also, the application should be highly available. This is the front end IP. The back end instances, that load balancer will take care the health of it. But we don't use mostly the load balancer. We'll configure the application load balancer in the tomorrow class. Application load balancer will do at web level, web-based applications level, and path-based routing and like host-based routing also is possible with the application gateway. So this you try to enable that auto scaling group also, or VM scale set also try to enable to this load balancer. Okay, we have the scale set, right? That scale set also try to do it. It's supposed to work that. Okay, so the outbound rule we are getting some port conflict. So try to work on that also. So tomorrow we'll discuss application gateway. Then we'll go for traffic manager and CDN also. And when we use Azure AVD, normally we'll have a NetScaler in the Citrix environment. Azure AVD automatically provides a traffic manager for us. Means always we'll get from the nearest location, the desktops can be delivered to the users. So like this, Azure automatically provides that traffic manager in the Azure AVD. Okay. Before that, try to configure scale set. From the scale set to create the load balancer. Even if any of the VM goes down also in the backend, here we don't have any impact because the another instance or another VM would be there. Okay. So try to configure the scale sets and this load balancer. This front-end IP is opening the Nginx itself, but you can configure the path also. Based on the host name, it need to redirect to that Finexo page also, we can configure. Then, by default, that address itself will redirect to Finexo. But tomorrow we'll configure, if it is /Finexo, it need to redirect to one backend pool. And if it is / maybe another website, maybe sports is another website, to that it need to redirect to another backend pool. That is called as path-based routing. For the path-based routing, this load balancer is not enough. We need to go for application gateway. So that we will configure in the tomorrow class.
Okay, sir.
Okay, sure.
Okay.